In this video, I'll show you how to make a binary phase diagram with experimental data. Let's say we are looking at two different chemicals, A and B, over here. X of A is a mole fraction of A, X of B is mole fraction of B. When X of A is 1, we have pure A. The melting point of pure A is 316 Kelvin. And then if we add a little bit of B into A, well, the melting point of A decreases. So over here, when we add some B into A, let's say the mole fraction drops to 0.85, the melting point of A becomes 312 K. And then we can further drop the mole fraction of A, and correspondingly, the melting point of A also decreases. Now, same here. This is the mole fraction of B, 1.0. That means pure B. And let's say the melting point of pure B is 328 K. And again, we can add A into B and gradually lower the mole fraction of B. And that's why the melting point of B decreases as its mole fraction decreases. Given this three data points, you can determine the enthalpy of fusion by plotting the logarithm of x versus 1 over the melting point. Alright, the slope is negative enthalpy of fusion over R. Same here, you just need to plot the logarithm of the mole fraction of B versus the reciprocal of the melting point of B. And then you get a linear relationship. Using the slope multiplied by negative R, you get the enthalpy of fusion. Once you have the enthalpy of fusion and the melting points of pure A and pure B, you should be able to determine the eutectic point. Two numbers, the eutectic composition and eutectic temperature. Over here, I'm using this fake data. Let's say when X of A is 0.6, X of B is 0.4, we have the eutectic point. The eutectic temperature is 301 Kelvin. That means A and B both melt at this temperature. They have the same melting point, all right, in this mixture. And now I'm going to show you how to make the phase diagram. So mostly we just need to plot all these 7 data points, this 3, plus the eutectic point in the same graph. So what we do is we're going to translate these 3 data points in here, over here. Of course, when X of B is 1, X of A is 0, but we want to do this with the equation. And then we'll drag it down, right? The 3 mole fractions of A correspond to the 3 mole fractions of B here. What about the melting point? We'll just copy the melting point. So equal this, and then I'll drag it down. Right now we have 6 data points in these 2 columns. Now eutectic point. Right here, I'm going to just put equal sign here. Because right here, we have eutectic composition in terms of mole fraction of A, so I just need to copy this. Equal sign, the eutectic temperature. Maybe I should put this eutectic temperature here, just to remind you, this is eutectic temperature. Now we have all 7 data points. Select all of them, insert, choose scattered. Now you have a phase diagram, a binary phase diagram. You have melting points of A, you have melting points of B, you have mole fraction over here, you have the temperature, but we just need to make it a little better. Binary phase diagram of A and B. All right, and then we need to add axis. Over here, just temperature in Kelvin. Over here, this is a mole fraction. In this case, I think it's mole fraction of A. We don't need 1.2, so we click this. We get rid of this 1.2. We replace this with 1. Now it looks better. And then I click here, home, bold font, and black instead of gray, so it looks a little better. And then large font size, maybe 14, 12. 12 is good. 12 is good. Alright, so you have a basic binary phase diagram of A and B. And then we need to add some coexistence lines, label some phases. I just copy this. I think I just copy this as a picture. So Control C, I'm pressing Control C. And then you can make the phase diagram in a PowerPoint or in Word, either way you like. So I am using PowerPoint right now. I think the slide size is too big. I'm gonna shrink it. So design, slide size. Okay, over here. I'm not very sure about how big it should be. Maybe 5 by 3. Let's see if it look good. Oh, doesn't look good. So design, slide size, customize 5 and 3. Okay, and this time I'm gonna click maximize. Alright, maybe I just yeah, so you just need to use maximize. Now over here we have a binary phase diagram. And how can we make it like even better? We need to insert some lines. I'm gonna use this line here. Alright, let me change the color of it. You can use any color you want. I'm just using black color right here. The size should be width. Let's see. Oh, I think I just want to change the thickness. Format object 0.5. I'm gonna change it to maybe 2 points. Alright, and then I need some curves. Insert shape. I need some curves. Okay, this is I admit this is the hard part. Okay, this one is not good. So if you have a tablet, it's gonna be easier. You can just use a pen to draw it. But over here, I would say, let's see. Yeah, it's not too bad. Okay, it's not too bad. Okay, I got this side. And then insert shape. Okay, I'm pretty sure you can do much better than what I did. But anyway, let me try. Alright, double click to finish the drawing of the curve. Alright, we're almost done. Now we need to label the faces. So again, insert. I'm going to use text box, solid. This over here, it's solid A and solid B. Alright. Okay. Down there. Alright. And then I'm going to just copy paste this to here. This is just liquid. A and B. Well, also you can just say liquid phase. In a liquid phase, we understand A and B are mixed. Alright. And this region, we have pure A and mixture. So I'm going to copy this and put it in here. And maybe I should use a smaller font size. Maybe not 18, maybe 12, so that I can write solid A and liquid. Okay. over here, this is solid B and liquid. All right, and let's double check. We have mole fraction of A is 0 here, so this is pure B. This is pure B. And now we have a binary phase diagram of A and B. We have the melting points of B. We have the melting points of A on the other side, and we have the eutectic point here.